So this is Professor Hale. So all right, so here's the deal. So critical care drips have to be really spot on, right? So the orders might come written in all kinds of units, like milligrams per hour, micrograms per minute, micrograms per kilogram per minute. But at the end of the day, the pump only understands one thing, which is ml per hour. So that's where the dimensional analysis comes in. So if you set the problem up so the units cancel one by one, the math basically solves itself and points you straight to the right answer. So don't stress about the big numbers. Just follow the units like a road map. So if the units don't cancel out neatly to ml per hour, well, that's your red flag and something might be off. So the numbers matter, but the units will keep you safe. So this is a heparin view calculation. It's not about heparin, it's a framework. So the exact step-by-step process is used for critical care drips such as epinephrine or epinephrine, dobutamine, or dopamine, and other weight-based infusions. So once you understand this method, you can really apply it to any high alert medication. Okay, let's get into this. Let's start at question one. So a nurse is preparing to administer esmolol, 50 micrograms per kilogram per minute by continuous IV infusion for a client who weighs 80 kilograms. Available is esmolol, 2,500 milligrams in 250 ml. The nurse should set up the IV pump to deliver how many ml per hour? Round to the nearest whole number. So you can see we want to find the answer of ml per hour. So let's kind of step first. We just really need to convert the weight-based order to a single rate, right? So we already given the kilograms, how much the patient weighs in kilogram. So what we really need to do is make the dose specific, as I mentioned. So you want to multiply the 50 micrograms by and multiply it with 80 kilograms. So 50 micrograms times 80 kilograms will be as a result of 4,000 micrograms per minute. So that's the specific patient dose. So now that we have that, we can move on to step one. So step one is we really need to kind of write down. So this is where we're going to write what we're solving for the first, so the units guide us, right? So this is going to be the start of our kind of like our start of our chain in dimensional analysis. So we're going to start off with like we got to figure out what x is. So we got to try to solve x. And then we need to just have the ml per hour, and that equals. So we're going to set that up. And everything we kind of multiply will be arranged so the unwanted units will cancel out, and that will, so hopefully we'll be leaving just only ml per hour. Step two, we just need to start with the concentration in a way that helps us. So we will use the bag concentration and put the ml on top because that's our goal unit. And then we will have our corresponding, which will be 2,500 milligrams. So we'll start with that. Step three, we kind of that's where we start to build our chain. So so the units will cancel out from left to right. As you can see, I already set it up here on this slide here. So as you can see, you know, as you kind of say, as you point to each factor, right? So when you want to cancel the milligrams with the micrograms conversion. So you want to put the 1 milligram over the 1,000 micrograms. So you kind of can see the pattern here that I have in this chain on step three. So like we said, we're going to set up from left to right. And we want to make sure, like when we're diagonal, that the unit matches the top number diagonal. So you see where that 2,500 milligram, that milligram should be matching diagonal. So that's why I put that 1 milligram on top as in the numerator. So and then I would put the 1,000 micrograms in a denominator. Now moving on to the next one, right? So this is where I'm going to bring the ordered dose into play here because again, you see where that 1,000 micrograms, I have to go up to the numerator and put the 4,000 micrograms so I can cancel out the micrograms. You see where that pattern's going? Then I'm going to put it over 1 minute. So that's where my rationale is right there. So then you're going to move on to the 60-minute per hour. So you want to cancel out the units until you're only left with the ml and the hour. And you can see where I crossed it off here. So now that I set up my chain, now I can actually cross things off. Now I can actually eliminate the units. So I'm already crossing off the milligrams. You already see that. I'm crossing off the micrograms, and I'm crossing off the minutes. And now we are already leaving the mLs and the hours. So we can solve X. So the next step is, do you really want to multiply the numerator and the denominator? So the numerator, you really want to multiply all the numerators on top there. So you're going to multiply 250 times 1 times 4,000 times 60. And that's going to leave you with 60 million basically, right? And then you're going to go down to them, you're going to multiply the denominators straight across, just like you did with the numerators. So the denominators, you're going to multiply 2,500 times 1,000 times 1 times 1, which is going to leave you 2,500,000. You could see how I kind of I eliminated the zeros there. So on the bottom one, I only have 5 zeros. So then I'm going to move up forward, which is more zeros, but I'm just going to eliminate 5 zeros, which I'm going to really just divide 600 by 25, and that's going to leave me with 24 ml per hour. So we just solved the X. That's going to be what the nurse is going to set up the IV pump to deliver. She's going to deliver 24 mLs per hour of Esmolol. Here we got another one here. So question 2. A nurse is preparing to administer epinephrine 4 micrograms per minute by continuous IV infusion. Available is epinephrine 1 milligram and a D5W 250 ml. The nurse should set up the IV pump to deliver how many mLs per hour. So you kind of get the pattern here with any of these kind of infusions. Our ultimate goal here at the end game, we really want to solve the ml per hour. We want to figure out, what are we going to set the pump up at? What are we going to set the pump to the settings of ml per hour? So it's kind of almost the same step as the previous slide as Malal. The only thing different is we don't have the weight provided. We don't have to add in that equation. We're just going to solve it at face value here, right? So again, we're going to set up because we really want to figure out the ml per hour, so we're going to actually keep that at the beginning at the left, right, as you see in step 2. We did the same thing in the prior, right? So we're going to actually put what we have on hand. So we have the 250 ml, and we're going to put that at the top there because we want to have ml per hour. We want to set it up. We want to set up our chain so where we can actually eliminate our units. So all we are left now with is ml per hour. So we're going to start with what we have here. We got 250 ml over 1 milligram. So as you can see in step 3 over here, that's where we're going to actually set up again, because we want to cancel out these units. That's a big thing. If we can't cancel out these units like we should be, then something's off. We're not setting up something right. So you always want to look diagonal. So from the bottom up to the diagonal, we're going to put 1 milligram to 1,000 micrograms. We're already going to cancel out the milligrams, right? We already canceled them out. So now we need in micrograms. So we got the 1,000 micrograms. We're going to have the dose that we have already. That's the order dose, the patient dose. So we're going to put 4 micrograms over 1 minute. So we already going to cancel out the micrograms, right? So we already canceled them out. So now we're going to move on to our time. So 60 minutes is in 1 hour. So we're just going to do the 60 minutes over 1 hour. And here we are crossing out the minutes here. So what does that leave us now? Now it just leaves us with, now we have, all that we have left is the ml per hour. which is great, right? So now all we have to do is multiply the 250, multiply it by 1 milligram, multiply it by 4, multiply it by 60. So that's where we're going to get, multiply that. And then we're going to multiply the denominator, which is really 1,000 by 1, so it's going to be 1,000. So whatever you got from the numerator straight across, what you multiplied that, you're going to, which was 60,000, you're going to actually divide it by 1,000. And therefore, we already solved x. We solved for x, which is 60 ml per hour. So the nurse is going to set the IV pump to deliver 60 ml per hour. All right, here's another infusion here. So this is where you're going to round to the nearest tenth. So when you look at these type of questions, I want you to really slow down and read the wording. We have to round, we got to round, but we really need to pay attention to the wording and what we have here. And just slow down and just take your time. If you do this process, if you do this dimensional analysis to set up your chain and to set up, you're going to get to the correct answer. And as long as you're able to cancel out the units and only leaving with ml per hour, then you're on the right track here. So let's solve this question here. A nurse is preparing to administer dopamine 3 mics per kg per minute via continuous IV infusion to a client who weighs 64 kilograms. Available is dopamine 400 milligrams in a 250 ml bag. The nurse should set the IV pump to deliver how many mLs per hour? Round to the nearest tenth. So here we go here. Again, we're going to actually try to find the patient dose, and by that, the actual dose. So by that, we're going to actually multiply the 3 micrograms by 64 kilograms. So it's going to be 3 times 64, and that's going to be our weight. That's going to be our weight in kilograms. So actually we don't. I'm sorry. That's going to be our actual patient dose. So it's going to be 3 times 64. So it's going to be 192 micrograms per kilogram per minute. So that's going to be our actual dose. Here on the step 3, I didn't actually do that step in the beginning, so I just kind of wanted to show you that you don't have to actually multiply it in the beginning. You can actually create that chain setup and put that kilogram per minute in there as well. But it's just an extra step and it can be confusing. So that's why I always multiply the 3 micrograms by the kilograms, the patient's weight in kilograms, in order to get the patient actual dose. So I can actually skip that step. So anyways, we're setting up our thing. So we are looking for the ml per hour. We want to solve for x, right? So by doing so, we're going to take what we have available and we're going to actually align it with the ml. So that's why we have the 250 ml on the top as the numerator, and we have the 400 milligrams as the denominator, because we really ultimately want to end up with ml per hour, right? So then we're going to move on to step 3. So again, we want to actually cancel out our units. So I'm going to put 1 milligram because it's 1 milligram equals 1,000 micrograms. So that's why it's just kind of knowing just your simple conversions there, your metric conversions. So 1 milligram over 1,000 micrograms. I'm already canceling out right here. I'm already canceling out my milligrams. You can see that right there. So now I'm moving on to the next one here, right? So I have the actual dose here. So it's 3 micrograms per 1 kilogram. So I already have that here. So now I'm actually going to cancel out the micrograms. And then you see how the pattern, you just keep going. You got to make sure that these units are going to be aligning up, right? So now we have 1 kilogram. So the patient weighs 64 kilograms, so we're going to line that unit up with the 1 kg. So We have 64 kilograms over 1 minute. So now that we have that, we're going to cancel out the kilograms. Okay, we're going to move on. So we have 60 minutes in 1 hour. So we're going to have 60 minutes over 1 hour. So we're going to actually cancel out the minutes. You see the pattern here? So make sure if you have these aligned, these units aligned like we have here, then you're doing something right. And if you have the ml on the top here and you have the hour on the bottom, then you're in the right direction. You're heading in the right direction. So what you need to do right now is, as obviously, we're just going to multiply straight across for the numerators. We're going to multiply the numerator right straight across, right? So we're going to do that, or whatever we get for that. We're going to divide it by the denominator because we're going to multiply whatever right straight across of the denominators. So we're going to multiply whatever we got. So ultimately we have 7.2 mLs per hour. So that is that's our answer here. So I hope this is kind of clicking with you. This is kind of helping out. So the more you do this and get familiar with this, you'll be more comfortable with doing this when you have these exam type questions. But it's good to keep practice on this. All right, let's move on to the next one here. I kind of mapped it out here for you. This was on the other critical care practice sheet, so you can always certainly practice more. So we have a 6 microgram per kilogram per minute of dopamine, and the patient weighs 198 pounds. So your concentration is 800 milligrams over 500 ml. So what is the milliliter per hour rate of the dopamine? So we really first need to convert the pounds to kilograms. By doing so, we're going to take 198 and divide it by 2.2, and that's going to be our kilograms. So it's going to equal to 90 kilograms. After we figure that out, there's a few steps that we have to take we have to slow down and do before we get to the chain, before we get the dimensional analysis. So then we actually figure out the actual patient dose, right? Um, per the kilogram specific. So that's when we multiply the 6 micrograms per minute by 90 kilograms. Therefore, the actual patient dose will be 540 micrograms per minute. So now that we got that figured out, we already have our numbers. So that's what we really want right there, the actual dose. So now we're going to solve for x, right? So you can see where we already set it up on the far right. So we want to start at the want to start at the far left and work my way to the right. And ultimately end with ml per hour. So now that what we have on hand, we have our concentration. So we're going to put the 500 ml on the top because we want to align it with the ml. And then we're going to put the 800 milligram, what we have at hand, the dose. So you can see where we still have to convert. So we have 1 milligram over 1,000 micrograms. So I'm already canceling this out. So then I got 1,000 micrograms here. I'm going to actually put the actual dose to the next, moving on to the right, 540 micrograms over a minute. So now I'm just kind of canceling out the microgram. You can see I still align. As long as you can do this, you have these units matching like this, you're doing something right, okay? You're in the right direction. So I'm already canceling them out. So now I'm going to move over to the time, and then I'm going to put 60 minutes over 1 hour. So now I'm just going to cancel out the minutes. As long as you cancel, that's our goal, is to cancel. Like I said, this is a roadmap. These units are our guide as a roadmap to get where we need to be, to our destination, which is the answer, right? So here we go. So we ultimately are left with hour per ml. So we have something's right here. So again, we're just going to multiply straight across the numerator, straight across, and then we're going to multiply the denominator straight across. we're going to divide the numerator, total of the numerator, and then total of the denominator, and then this is what we ultimately will get. This is our final answer. So that is kind of your answer. If you're going to actually round to the nearest whole, which would be right here, it would be 20 mLs per hour. If we were going to really round to the nearest whole number. If you're going to round to the nearest tenth, then you would actually, this would actually be 20.3. Again, we have another equation. So I'm hoping that this is kind of clicking in for you guys. It's clicking with you. It's kind of like you're trying to fit, you're getting a little bit more confident in solving these types of these problems, these equations here. So here we want to infuse the nipride, 50 milligrams. What we have is 50 milligrams in a 500 ml D5W at 2 mics per kg per minute for a patient who weighs 58 kilograms. So we don't really have to convert the weight, right? Because it's already there in kilograms. So what is the milliliter per hour rate of nipride? So first we want to get the actual patient dose. So we have to multiply the 2 micrograms by 58 kilograms. And that equals to 116 micrograms per minute. That's the actual patient dose. So again, we're going to set up from the far left. That is, we got to solve for x. So again, you're kind of seeing the pattern here. So you're going to start off with the dose we have at hand, right? And we're always going to put the ml on the top there first, because we really want to actually have the ml diagonal. We want to have the ml on basically want the ml at the end result at the numerator. The hour should be at the denominator. So if you kind of keep that in your mind, hopefully I'm not confusing you too much. So we're going to start off with actually the dose on hand. That's why we're starting with that. So we got 500 mLs and the dose would be 50 milligrams. We're starting off with that. So again, we're just, need to align with our units here. So we got 1 milligram over 1,000 micrograms. So we got the actual patient dose to the next one. We're moving over to here. So that's where we got 116 over a minute here. So now we're actually crossing out, we're eliminating our units here. So now we have canceling out our units. So now we're moving on to the time. So I have 60 mN. So now we're just going to jump over to the time because we really need to have something here to line up with. So we're going to have 60 minutes per hour. So I am already canceling out right here. That pretty much leaves us with the hour and the ml. And all we have to do is pretty much multiply 500 by 1, multiply 500 times 116 times 60. Same thing with the denominator. We're going to multiply 50 times 1,000, and then we're just going to divide whatever what you come up with. And will be our answer, 69.6. So if you're going to round to the nearest whole number, we're going to round it up to 70 ml per hour. I kind of left this one here because let's just kind of figure this one out right on our own here. So we have dopamine prescribed at 10 mics per kilograms per minute. You have 250 ml bag of D5W and a 400 milligram dopamine in it. The patient weighs 80 kilograms. What is the milliliter per hour of dopamine? Again, this is what we want here. We want milliliter per hour. So we got to solve for x, right? And we got to equal for the ml. Excuse me. I know my handwriting's terrible. If you want to set it up like that to kind of make it more visual. All right. And so now we have the dose on hand. So we're going to start from left all the way to the right here. So what we have now is a 250 ml bag, and we have the dose here. So we're going to start off with that. So we got the 2 ml because it's matching the ml. The units we're looking at right here. The units are our guide. So use them. So we have 250 ml. I wish I had a pen. I'm not really good with that. So anyways, it's ml. And then we have the 400. I can't even type this. And then we're going to actually multiply that. Obviously, this is milligrams. We're going to say that's milligrams. So then we have 1 here. So I'm just going to bear with me on this. I don't have a pen. So then we're going to go to 1,000 micrograms right here. Some of my computer is not really that great. All right. Terrible. But anyways, we're going to move on. So now we're already canceling out our milligrams. So we're canceling out our units here. So this unit is acting as my guide. So I'm moving on. So now that I have that, I'm going to go by the dose here that we have here. So we have 10 micrograms per kilograms per minute. So we're like, again, we're going to actually multiply 10 times 80, and that's going to give us 800 mics per minute. So we're going to go with this here. Oh, it's painful to watch this. Anyways, and then we're going to do per minute. And we're just going to keep going here. So then we got the one, we're going to do 60 minutes here. Just pretend that's minute because I'm not really good at that. All right. So right here, I'm already going to cancel out the micrograms. So they're acting as my guide here, right? I'm already eliminating the minutes here. So all I'm left with my units are, I have ml and I have my hour. That's what I want left as far as when it comes to this chain into this equation. I want to have left of the ml and the hour. So what I'm going to do now is pretty much multiply, you know, so I'm going to multiply 250 and I'm going to multiply that by 800 times 60. So that's going to give me like 12. So that's going to give me like 12 million. Wish I had that money. Anyways. All right. And then, so that's my numerators there on the top. So now I'm going to multiply the bottom here. So 400 times 1,000. And that's going to leave me with 400,000. Which I can only write big. If you really want to make it easier for you, you can actually eliminate these zeros and make it easy. So you don't have to have all that. So you can just eliminate this equal amount of zeros. You can't eliminate more than what you have. So you take the 5 zeros here and you eliminate 5 up here and you eliminate 5 zeros here. So really you can just, divide 120 by 4. So you can actually do that. If it actually makes it easier for you. Sorry for the mess, but it is what it is. So that would be 30. This would act equal to 30. Obviously, I'm using a calculator because it's late and I can't really think at this point. But you got 30 ml per hour. and that's going to be the rate, ml per hour. So I'm hoping that this video can will help you, solve these types of questions. But, feel free to come to my office or email me or reach out to me if you need any further assistance or guidance when it comes to these type of problems. But these are the kind of type of problems that you most likely will be seeing on your exam. All right, I hope this helps, and I'll see you next time in class.